Hello folks, and welcome to this video. We're going to look today at the three quantities speed, distance and time and how they relate to each other. Now hopefully you've got pen and paper ready to take some notes. If you don't, feel free to go off and get that just now. But however, if you're ready, then let's get started. Speed, distance and time are three of the first quantities that we tend to meet in a GCSE science course. They're relatively familiar and simple quantities to appreciate, and so therefore it's a nice entrance level into using calculations and understanding how formulae work. Now often I notice that when I ask students to define speed, they'll answer in a certain way. They might say, for example, how fast something is going. They might talk about the rate of travel. Or they might give an example. They might say if something's moving quickly, it has a high speed. Now in science, in physics particularly, we are very careful with our definitions. And so we need to be a bit more quantitative in this sense. And I'm going to show you an example of a definition that you need to use, which will be able to get you marks in your GCSE science papers. When we're defining speed, we use the quantities distance and time. So one way of defining speed is as follows. That speed is the ratio of distance to time. There's a lot going on in here, so I'm just going to unpick a few things. Firstly, I've written the words average. Notice here we have average speed is the total distance traveled divided by the total time. That's also another way of defining specifically average speed. We also have to be careful with our symbols. Generally in a GCSE course we use the symbol V, not the symbol S. And I'm really hoping in my PowerPoint I've not made that mistake. Please feel free to call me out if I have. And then we've got units. Your units are in the square brackets. So we have meters per second. And then we have meters and seconds here. These are the SI units of speed, distance and time. So it's really important that we define things in a clear way. As you can see, it's a very different definition to the ones I gave at the beginning, not just how fast, but giving the ideas of distance and time and how they relate to each other. Now, often you'll have to do calculations with speed, distance and time, and one helpful thing that we can use is the triangle. For now, we're just going to set our triangle up. I'm going to put distance on the top, I'm going to put speed on the bottom, and time also on the bottom. It can go left or right, doesn't matter. Why do we organize the triangle in that way? Well, let's look at our definition again. We've got V is the ratio of D to T. Speed is the ratio of distance to time. Well, if I was calculating speed, V, I would need to divide the distance divided by time. And that's why we put the distance in the top and the time in the bottom. And then the speed is also on the bottom here. If I want to calculate speed, I cover up V, and that's D over T. If you like, you could try and rearranging this now to try and calculate, say, distance. If I knew the speed and the time, how would I calculate the distance? Have a think for a second. When you're ready, watch on. Here's the way you could do it. If you take our D and cover it up, then we're left with V times T. In other words, D is equal to VT. Finally, you could be asked to calculate the time. Give that a go. Well, time is on the bottom. If I cover up time, distance divided by speed. There we go. Time is distance divided by speed. So these are the three equations the three forms that this equation could take. Obviously, you're not expected to remember all of these. The GCSE course should not be a test of your memory for all of these, and remembering one is enough. You need to be able to rearrange them. I like to remember the top one here because I usually express it in a mnemonic. A mnemonic is a sentence which allows you to think about what order certain things go. So if we look here, this is my way of remembering it. D, V, and T. Distance varies with time. D equals V times T. That tells me that D, V, and T go in a particular order, and usually I know that the first one is the equals, so distance varies with time. This is just my way of remembering it. It's not necessarily your way. However, in a subject like this, we do need to find our own little strategies to make sure that you remember one equation, not all three. Now, please do feel free to pause the video at this stage to take any notes you might need. However, you are ready to go on, we're going to do some calculations, so we would need to have a calculator for that at this point as well. So, first one here, we're going to be given a question which is a train travels at 50 meters in 5 seconds. At what speed did they travel? Go and take a second to try that using the triangle which is on the screen. Now we're obviously going to be using our equation here. Speed equals distance divided by time. We know the distance is 50 and the time is 5. And therefore our speed is going to be 10 meters per second. Nice and simple example there, however it does show you the sort of quality that we're looking for in a physics problem. We're expecting the formula, we're expecting the numbers, and then the answer expressed with a unit. This is the way to get the guaranteed marks on your questions. Let's try another one. We're told a skater travels 20 kilometers in 4 hours. At what speed did they travel at? Notice there that the units are different. Don't need to worry about converting into SI, just do the calculation and express them in a particular unit. Again, we've got speed equals distance over time. We're going to now do 20 kilometers over 4 hours. This time I put the units in just to show you that you don't always have to be meters and seconds. Well, keep the units there. 20 over 4 gives 5 kilometers per hour. So you notice there we don't always have to state the units in the SI form. We can put the units in whatever's convenient according to the question. Now, it may be that the question requires you to change it. In this case, it's not. This is just using the equation. Let's try one final one. A girl cycles for 3 hours at a speed of 40 kilometers per hour. Let's be honest here, 40 kilometers per hour is very unrealistic, but we'll just go for the number. What distance did she travel? Hopefully you've had a go. Now a lot of students will give me an answer here which is 13.3 kilometers per hour. However, in that case I know that they've perhaps not read the question very carefully. Here we're asking for distance. So if we want to do that, we cover up distance, speed times time, and actually then we're going to do 40 times 3, which is 120. So just be careful, make sure you read the question carefully to make sure that you are following and answering exactly what the examiner or the question setter is requiring. Okay, that's enough from me just now, folks. I hope that's been easy to digest. You now need to apply what you've learnt in some practice questions. I look forward to seeing your work.